Hey everybody, welcome to video number 8 in the UE5 Vehicle tutorial series. This is part 2 of the Niagara smoke and skid emitters. In this video we will be covering the blueprint part of the system. Before we get started, I would like to remind everybody that I now have a Patreon page, and it would mean so much to me if you could subscribe to it. Link is in the video description, as well as the link to the Discord channel. Feel free to join that as well. Lots of good people on there, lots of fun, and I'll be answering your questions in real time whenever I'm online. Okay, now, first thing to do would be to reopen the Niagara emitter system we've made in the last video. So let's go to my tutorial folder. That was Niagara drift marks. We're going to add a couple of variables to it in order to be able to control them from the vehicle blueprint, and those are going to be the spawn rate for the smoke and also the opacity of the skid mark. So to do that, let's go here to the left in the user exposed section, click that little plus, make new common float. So as I said, the first one will be smoke spawn rate. We'll make another one right away. So plus make new common float. That one is going to be the drift mark opacity, like so. You'll have to remember those names as we did for the engine sound in meta sound, where we set the RPM value. In the blueprint, we're gonna have something like set parameter by name, and we're going to use that to set these two, so be sure to keep those names in mind. Now for the smoke, what we're going to do is we are going to find the spawn rate in the list. Now you can see the spawn rate is just a regular float. We'll click the little arrow to the right here, and we'll search for multiply float here. In the A, we will set 20, which was our default value. In B, we'll click the arrow here and search for our smoke spawn rate. So this float variable here will serve as a multiplier for spawn rate. So we'll give it a value anywhere between 0 and 1, and that's going to be about it. Now if we go to the skid marks, into the initialize particles section, the color here we're going to replace with a make linear color right here. And what that gives us is we can add a number to each of the RGBA channels. Now RGB will be almost 0 like it used to be, to make it black, and the alpha is going to be our variable here, which was named drift mark opacity. Okay, with that done, if you leave it like that, you won't be able to test the system in the world, because the default values for these are 0, so you're gonna spawn 0 smoke and have an opacity of 0 for the skid marks. So just for testing purposes, let's go into that section here that I said I had no idea what was doing in the last video. We can actually see the user parameters here. Click on there and set the default values for these. We're gonna set them both to 1, because it would have been just too simple for you to click the variable here and have that little section appear, or just right click and set default variable. No, you had to actually know where it was in the menu, because Niagara. And now that's done, finally, no more Niagara for me. Let's open our vehicle blueprint, like so, and we will be creating a timer to execute the drift detection code, because it is absolutely not necessary to do it on event tick. Now again, event tick here everything you put after it is going to be executed each frame. So if you get 60 FPS, this code is going to be executed 60 times per second, which is vital for some things like smooth camera movements, for example, and absolutely unnecessary for a lot of other things. And part of the optimization would be to use that event tick as little as you possibly can to reduce the amount of code that is ran every frame. And since we're doing drift marks and we're using a ribbon particle, so it's always going to be smooth, instead of a sprite we need to spawn each frame, we can actually afford to be doing this a lot less often, and so we will. So the first way here would be to right click, create a custom event, which I will be calling timer for, obvious reasons. And you see here that little red square, output delegate. You can drag off of that pin and set timer by event, and then you can plug that into the big and play and not into the timer itself. So now on the event big and play, that gets executed and turns that little event here into a timer. Now you want to set it to be looping, and the time here is actually the delay between the execution of that custom event. So I've set mine to 0.2, which will cause it to execute 5 times a second, which is plenty enough to get the skid marks to look good. Now with that done, we're going to create a function, because it's going to be a very, very big graph, so you don't want it in here creating a huge cluster. So we'll go to the left here, functions, hit the plus, call it something we'll remember like detect drift. And just because I'm gonna forget about it and wonder why it's not working, before we start adding anything to this function, we'll go back into the event graph and make sure we execute it on our timer, dragging it into the graph, plugging it like this, and we're done with the event graph. Now we need 4 kind of sockets to know where to spawn the emitters. I could be adding sockets to the skeletal mesh of the vehicle. If you do that though, you're going to be attaching those sockets to the wheels. Those bones are spinning, and so it is really bad to attach your skid emitter to it because it'll be spinning. So what I did instead is add 4 components, scene components to be more specific. Let's have a look at that right now. It's just here, it's just called scene, and it's basically an empty component that you can use just to get the coordinates of it and attach things to it, for example. So I'll be going here, instead of perspective, I'll be going into the top view. And I'll just create 4 little scene component here. I'll be calling that one emitter front left. Then I'll just duplicate it, keep the same Y position, and set the, actually did I say Y? Keep the same X position and only mirror the Y by removing the negative, like so. And now you have your 2 emitters. That one is going to be front right, and then duplicate these 2 again for the rear, like so. Now the position of these isn't vital, as they're going to be spawning a bunch of smoke, so you won't really see them, but you still want to get them close enough. So that one is going to be emitter rear left, and that one emitter rear right, like so. Let's actually make sure the height is correct. It is spawning on the ground, slightly above the bottom of the wheel, which is perfect, because you don't want it clipping through the ground and being invisible for the skid marks. And now that we have these, we have everything we need, and we can start focusing solely on that blueprint. What you're going to want to do is, sorry about that, go into the component here and get the variable we've set before, the one we used to get the engine RPM and whatnot. Just in case you don't remember that variable, or you haven't seen the previous tutorials, let's go back in the event graph. And here on Beg and Play, I get the vehicle movement component here from the component list, and I cast it to wheeled vehicle movement component and set the output of that as a variable for a very simple reason. If you just grab the component here, place it in the graph, and try to get the engine rotation speed, you can't find anything. Once you've cast it and made a variable out of it, you can drag off of it and get the RPM and max RPM and a lot of other values that you're going to need. And again, a cast is an action that you have to execute. So if it's possible to only execute it once and then set a variable, that's also good for optimization. And then you get a variable here that you can use anywhere in the graph. And so that's that, because I get asked a lot, because I guess I put the name kind of confusing. So when I put this variable into the graph, people actually will think I'm using the component here, and they'll wonder why they don't find the values I'm using. And so that's why right here. Okay, back to business. In our detect drift, we will get the wheels, variable vehicle get wheels, and we will do a for each loop. And what that does is we are going to execute the loop body part here for every item inside of this array. So if you have 4 wheels, this is going to get executed 4 times. If you have 8, execute that 8 times. And every time it gives you the index of that array, so you know if it's the first, second, third, or last wheel. That's going to be very useful. Now I will add a little condition here, because I only want to detect the drifting for the rear wheels, because this vehicle is a rear wheel drive, and I don't think I'll be spawning a whole bunch of smoke from the front wheels, since they can't really do a burnout. And so I'll drag off the array index, type in range integer, set the range to be 2 and 3, not 23, 3, because an array will go from 0, 1, 2, and 3 for the 4 wheels. And if you go back into the vehicle component, wheel setup, you'll see here wheel 2 and 3 are the rear wheels, the ones we want. So we'll plug the value into a branch right here. And now anything after here will only be executed for these 2 wheels. Now we do want to get a variable called wheel state. Wheel state here is asking for an index, which we have right here. Let's already start with the reroute nodes, so we don't get a big mess that we have to sort out later. Now the wheel state here we can break Or, sorry about that. Oh, we can't split it. Okay. We're really gonna have to break wheel status. And that gives us a bunch of variables such as in contact, which in theory will only be true if the wheel touches the ground. But for some reason is always true even if the wheel is in the air. So completely useless. Thank you, Epic. We do have a variable here that we can use, which is, let's, I don't remember the name, so let's scroll down to game, component, wheel vehicle, and you have a variable here is in air, which we can use. So right away, let's put another branch. Oops. Right after the first one, because again, we don't want to be doing anything if the wheel is off the ground. Something like this. Make some room. Okay. Now we also want the branch to return false if two things. Slipping or skidding. Those are the two things we're gonna check for. So we want either one of these to be true and is in air to be false. Now when you type in not, it'll select the not equal, which is not the one we want. In UE4, whenever you typed in not, it would automatically select the not boolean, which is returning the inverse of the boolean value you put in it. And so if that one is true, this is going to be false. And if one of these is false, then the branch is going to return a false. So by doing that, we ensure that the wheel is either slipping, skidding, and is not in the air. If that makes any sense. Okay. Now with that done, sorry, I move stuff around a lot for reasons, just to be more readable and easier for you guys to follow. By the way, check the video description. I will be pasting that blueprint inside of the Pastebin website. So if I ever go over it too fast and you don't have time to read or something, and you just open up the Pastebin and you can inspect the blueprint there, or even copy and paste it. And okay, now we'll go one step at a time here because we have a lot of blueprint to add. First of which would be to make an array. Actually, no, let's keep the array for later. Let's spawn actor from, actually, nope, Niagara, spawn system attached. That's the one we want. In the system template, you are going to look for Niagara drift marks, which is the one we just made. That one is the one I made before off camera. This is the one we made together. Now attached to component, we are going to drag off of that and create a select node. Select, again, we'll need 4 pins. Yeah, we'll need 4 pins. And we will need our index again. Now we're only going to be using 2 and 3. Let's grab the order of these index 2 and 3 in the vehicle movement component. 2 would be wheel rear left. So emitter rear left will be our option number 2. And I suppose it would make sense for emitter rear right to be option number 3. Okay, now options for these. We have, actually, I believe we don't need to change any of these. And so what that does basically is just spawn the drift emitter we made and attach it to whatever scene component we need, depending on which wheel we're on here in the for each loop. And basically when we stop drifting, we're going to detach it so that it stays in place and the skid marks on the ground don't disappear as it would if we were to disable or kill the emitter. And that is it for that. Now that we spawned the emitter, we have a couple variables we can set in it, and we'll do that by setting set Niagara variable float, which is right here. And we are gonna set, let me reopen our Niagara emitter because I forgot the names that I've put. And that would be the smoke spawn rate. Beautiful. Again, having 2 monitors is awesome, and it's also such a pain. So smoke spawn rate. And what I'm about to do is going to look weird, but I'll explain. We are going to get the slip magnitude here, drag off of it, and type in sine. Now, that was the wrong one. I'm sorry. I said slip. Slip magnitude. There you go. Now, the slip is the amount of sliding in the forward axis. So whenever you brake and the wheels lock up, you're getting slip. Whenever you're doing a burnout, you're also getting slip. And when the tires are drifting or slipping sideways, this is going to be a skid. So that's important to remember which one is which. Feel free to add comments in here just so you can differentiate them. Now for the sine node, basically what that does is return 1 for positive, 0 for 0, and -1 for negative. And we're using that because we don't want to spawn smoke if we have a negative slip. Basically, if we do a burnout and the wheels are spinning too fast, we'll get a positive value and we'll spawn smoke. And if you pull the handbrake and the wheels lock up and you get some slip, but it's going to be negative, then we won't spawn smoke. And we'll just plug that here into the value for the smoke spawn rate. Now if you're afraid you're gonna do a typo here and have an error and look for it for hours, you can go back into the emitter here and just select the name, copy it, and paste it in here to make sure you don't make any mistakes. Okay. And now we need an array. We need an array to be able to get the skid emitter that we've spawned for each wheels, so that first we can check if there's already an emitter spawned for that wheel, and 2, we need access to that variable to be able to detach it when we stop drifting. So we'll set an array of the emitter here that was spawned. We will promote it to a variable, which we're gonna call, I guess that would be drift mark, or just drift emitters. Let's keep it short. And we're not going to set it here. We're actually going to click on it, go here on that little arrow, and make it an array. And then we'll drag that into the graph. Then set array element. The array element would be the emitter we just spawned, and the index of it would be the wheel index we get from the for each loop, which is right here. So let's not make that a spaghetti this early on in the process, because we still have much to add to this blueprint. Now, in case you're wondering, yes, I believe I just might have OCD. Might have. And that's actually good for you, because it makes for a very nice, easy to read graph. Now we're spawning it, okay? And we are setting an array, but we don't actually want to spawn it more than once. So let's come back in here, move that all out of the way. Okay, and add another branch. That branch, we're gonna check against the array we just made. So let's get our array, and we will get from it let's try to jam that up here without making too much of a mess. So this again is the array index from the for each loop. We want to get that, make sure it is equal to nothing before we actually spawn one. Like so. Fabulous. So now let's recap a little bit, because this is getting out of hands. We're checking for each wheel if that wheel is not in the air, and also if it is either slipping or skidding. And if that's true, we are checking whether or not we have an emitter already spawned for that wheel. Actually, we're checking if we don't have an emitter. If it's true and we don't have an emitter spawned, we spawn one. And we set the array so that the next time we check, this one here won't be equal to nothing and will trigger this output instead. Let's make more room for more stuff. And if that's the case, then we already have an emitter which we will need to update. And the updating part of it would be to set two variables inside the Niagara system. These would be smoke amount and the skid opacity. So let's copy and paste that here twice. Like so. Plug the false into them. The target would be, again, our skid emitter with the proper index. That's going to be our target here. There you go. Nice and pretty. Yeah, something like that. And again, smoke spawn rate, and the other one was drift mark opacity. And again, same as before, we are going to get that sign here to set the smoke spawn rate. Because although you are still drifting, you may have released the throttle and not be slipping, but still be skidding. In which case you don't delete the emitter, you just update it to stop spawning smoke. But still, the drift mark opacity might be more than 0. And the way we determine that is we will get the magnitude of the slip and drift. So the slip angle, let's make that an absolute. So it's always positive, because we don't care if it's positive or negative. And we are going to map those, because we need values from 0 to 1. So map range clamped. For the slip, I've actually spent quite a lot of time with print string trying to figure out what these values are going to be in the range of, because we don't have any documentation on what these are and what kind of units are they. Slip angle is, I suppose, in degrees, and that's actually the wrong one again. Sorry, I'm really tired. We want to get the slip magnitude, not the angle. Although the angle could be useful as well later on. Not today. And so the slip magnitude, I have no idea what it means. Is it like a velocity, you know, in centimeters per second? Is it a multiplier of something? Is it a force in newtons? We don't know. And so I had to do a lot of fiddling around to find out what good values would be for those. And I figured out the best would be from 600 to 1000 to give us a value from 0 to 1. That's for the slip. Now for the skid. For the skid, those values are going to be from 1000 to 1500. Again, for abstract reason, because these are what the print strings were in between of whenever I was drifting. And so we're going to add those together. And we are going to clamp that. Clamp float. Clamp it from 0 to 1. And what that does is, if we're not slipping, the value is going to be less than 600. This is going to return 0. And if that one is 1, then we add 0 plus 1. All is good. If we are slipping, this is 1. And we're also skidding, and this is 1 as well. We add them, that makes 2. And so we just want to clamp it to make sure we don't get more than 1. Because we are using this value inside our skid opacity right here. Okay, like so. I wish I had a way to make this prettier. Whatever. The nodes, they're all different sizes. It bothers me. Okay, that's that for the updating of the already existing skid emitter. Now all that is left to do is to detach the emitter whenever we're done skidding or slipping. And for that, we will use the only output we haven't used yet, which is going to be the false here. Actually, we're also going to detach the skid marks if we are in the air. And so from there, I'm going to add another branch. Yeah, whatever. Let's actually collapse that to a node. Just select everything, right click, and collapse to node. And give it whatever name. We're never going to use it again. We just want to move it out of the way. Something like that. Keep it close by just in case we need it at some point. But we won't. Okay. Okay, that's pretty. Let's go. Now again, we want to make sure. I'm actually going to copy and paste that one. Now if we're not drifting anymore for any of these three reasons, copy that, paste it. We will check whether or not we have an emitter existing for that wheel that is not drifting. And we need to drag off again that index right here, which is the wheel index from the for each loop. Okay, drag the output of that in the branch, and we are going to be using the true output. Because if we already have an emitter for that wheel that isn't drifting, then we are not equal to nothing, and this is returning true. Actually, no, this is wrong. If we have an emitter existing, that one is not equal to nothing, and so we're using the false output. And again, we will be setting the value here for the smoke spawn rate. We'll be setting it to 0 because we don't want to generate smoke for that emitter that is going to be detached. So the target of that would be the emitter here we get out of the array. The value for the smoke is going to be 0, and then we are going to detach from component right here. And we will keep world for all three of those, because whenever we detach the skid mark, we want them to stay exactly where they are with the right rotation that they have and the scale that they have. And lastly, once we've detached that component, we want to remove it from the array so that next time we start drifting again, we might create a new one. And so drift emitter right here. Actually, let's put another one in the graph, just get less wires. And we are going to set array element. We will set it to nothing, and the index of that is going to be the same index right here. Now I did warn you that this was going to get huge and messy, but we're done actually, finally. And if I did everything properly, we are going to get some pretty amazing skid marks. Although I did forget to mention, I just remember now, the is slipping and skidding actually have a threshold, and that threshold is set into your wheel blueprint. So let's go back into your vehicle folder. Mine would be the Porsche 911. Let's go into the setup. Wherever you put your wheel blueprints that we've created when we first created the car, And I'm only going to modify the rear wheel because that's the only ones I'm checking for drift. And you get here slip and skid threshold. And again, by trial and error and a lot of print string, I've decided the best values for these would be 200 for the slip threshold and 1000 for the skid threshold. And now onto testing. There you go. Skid marks, smoke. Actually, the smoke is never turned off. Let me see what's happening here. Okay, so something about the updating of the smoke. Actually, let me go back into the emitter. Make sure the spawn rate here multiply by smoke spawn rate. Okay, that is not where the mistake is coming from. I hate when this happens when I'm recording a tutorial. But it does show a little bit of debugging, I guess, so that could be a good thing. Now we are spawning it properly. That is good. Smoke spawn rate should be 1, because whenever we start driving we always do a burnout because there's too much torque. We are setting the array for the drift emitters with the proper index, although we are not sizing it to fit. Aha. I believe that might be the mistake right there. Yep, since we're not going to size it to fit, for just to make sure those indexes are static, what we need to do is go back into the array here and create those indexes and just leave them empty. Okay, now that we are actually setting the array, this here shouldn't be false, and we should go to the update state and stop spawning the smoke when we stop slipping. Never mind, made a little mistake. Here, if you go back into the slipper skid, you can see I've set the first map range to 600 and 100, which makes absolutely no sense. That should be 1000. Sorry about that. It happens. And then you spend 30 minutes looking at why is it not working. Okay, let's now see the results. As you can see, the skid marks are functioning. They look pretty good. You can see they fade out with the speed as we come to a stop. And as soon as we release the handbrake, the wheels start spinning again and make a little burnout. Go ahead and make an actual burnout. That's why you came here, didn't you? There it is. That beautiful smoke you worked so hard to get. Now I've just come to realize this video tutorial is now 45 minutes long, and with the part 1 being 30 minutes, that's upward of an hour and 15 minutes of tutorial just to get to make burnouts. And now I think you're starting to understand why I actually take so long to make those videos. Because now we're in 15 minutes for skid marks. Now imagine me trying to make a tutorial about AI or anything complex at all. So yeah, this is it. I promised I'd be showing you how to make them. Now it is up to you to decide if you want to spend an hour and 15 minutes watching videos about it. Hopefully you do though. And also hopefully you consider subscribing to my Patreon. The link will be in the video description, as I have mentioned at the beginning of the video. Also, feel free to join the Discord channel and ask any questions you might have. I will gladly answer them. And in the meantime, I'll see you soon.